Today, we're diving into a breakthrough that could completely flip how artificial intelligence works. We're going to uncover this hidden wall that's been holding back our most powerful AIs and reveal how the solution, incredibly, is all about teaching them to forget.
You know, we're right on the cusp of creating AIs that can tackle some of the biggest challenges out there, in science, in medicine, you name it. These models are showing some truly amazing reasoning skills, helping us push the limits of what we know. But there's a catch.
And it's a really weird paradox, right? An AI can blast through a super complex math problem in just a few seconds, but if you give it a problem that needs a long, continuous line of thought, it just kind of grinds to a halt. So what's going on?
Okay, so let's get into it. The issue is really baked into how these AIs currently think. It's a process that basically creates its own traffic jam, and a good way to picture it is as the problem of the infinite scroll.
So the standard way of doing things is called long chain of thought, or long co-OT. And here's the crazy part. To figure out the very next step in its logic, the AI has to go all the way back to the beginning and reread every single thought it's had so far. Just imagine trying to write an email, but for every new word you type, you have to reread the entire thing from the start. It would get impossibly slow, and that's exactly what's happening inside the AI.
This brings us to the villain of our story, quadratic compute cost. You can think of it like a thinking tax that just gets more and more brutal over time. The longer the AI thinks, the more expensive and slow the next thought becomes. It's just not a sustainable way to work, and it puts this hard ceiling on how deeply an AI can actually reason about anything.
So how do you get past this wall? Well, some researchers asked a brilliant, totally counterintuitive question. What if the secret to thinking for longer isn't about having a better memory, but actually being better at forgetting?
And this quote from the research paper is really the heart of the whole idea. Instead of just trying to deal with this exploding cost, what if you could just design a way of thinking where that cost never explodes in the first place? So here's the new approach, and it's a great analogy. Instead of that infinite scroll, imagine you're working on a small whiteboard. You solve one piece of the puzzle, you jot down the most important result on a little sticky note, and then you erase the whiteboard completely. You forget all the messy details, keeping only the one thing you need to move on. And this is the core of what's known as Markovian thinking. It's this powerful idea that your next step only depends on where you are right now, that little sticky note, not the entire complicated journey it took to get there. It completely breaks that chain of having to remember everything.
Okay, so let's look at how this cool idea was actually turned into a working system. The researchers built a method to do exactly this, and they called it Delethink. You can probably guess the name is a little nod to deleting old thoughts to make way for new ones.
So let's put them side by side. The old way, long caught, is just one massive, constantly growing blob of thought. Memory and cost just explode. But Delethink? It's totally different. It breaks the problem down into these manageable, fixed-sized chunks. It works on one chunk, creates that little summary, our sticky note, and only carries that forward. The cost stays low and totally flat, no matter how long the AI thinks.
Okay, so that all sounds great in theory, but does it actually work? I mean, can an AI that's always forgetting things really solve problems as well as one that remembers everything? Well, the results are pretty amazing.
Check this out. On a really tough math competition benchmark, Delethink didn't just match the old method's performance, it was actually a tiny bit better. This is a massive deal. It proves we're not losing any reasoning power by being selective about what we remember.
Now let's talk about the cost. To train the old long-caught model to think for really long stretches, we're talking about 96,000 steps of reasoning. It would take an estimated 27 months on a single top-of-the-line H100 GPU. That is a huge amount of time and energy.
And now look at the cost for Delethink to do the exact same thing. Just 7 months. That's nearly 4 times cheaper and faster. It makes building these super powerful models so much more realistic.
So being cheaper and just as smart is obviously fantastic, but the real jaw-dropping breakthrough happens when you push the model to reason for even longer than it was trained to.
See, a model trained the old way has a hard ceiling. If you train it to think for, say, 24,000 steps, it can't really get any better than that when you test it. It just hits a performance wall and flatlines.
But the Delethink model? It just keeps getting better. Because its cost per step is always the same. You can just keep feeding it more steps at test time.
And it keeps solving harder and harder problems, scaling its abilities way beyond what it was even trained for.
So what's the big takeaway here? What does this mean for the future? Well, it suggests that we've been thinking about AI reasoning in a fundamentally limited way. This research really opens up a brand new path forward.
This is why this matters so much. By smashing that quadratic cost barrier, this whole approach makes really complex long-form reasoning affordable. It separates how long an AI can think from how much it needs to remember. This could be the key to unlocking solutions to problems in science and math that are just way out of our league right now.
And this final quote from the paper really just nails the ambition here. We're not just talking about thinking a little bit longer. We're talking about a path to models that can reason for millions of steps. That's a depth of thought that's almost hard to even wrap your head around.
Which, leaves us with one last pretty epic question. If we had an AI that could just sit and think about a single problem for days or weeks without ever slowing down, what's the very first problem we should ask it to solve? I'd genuinely love to hear your ideas in the comments. Thanks so much for watching.